Let us look at proposition number 21 and 22 of works of Archimedes, specifically on conoids and spheroids. The proposition says any segment of a paraboloid of revolution is half as large again as the cone or segment of a cone which has the same base and the same axis. Let a cone X be equal to 1.5 times the cone ABC. Now here cone ABC is what? The apex is A, B, C. So we are talking of this cone. Therefore, cone X is equal to half the volume of the cylinder EC. Now, on what basis are we saying that? Because we have seen in a previous proposition that a cylinder is 3 times the cone. So the proposition says volume of segment of the paraboloid of revolution is equal to volume of cone X. Now let's prove this by proof by contradiction. Let the volume be not equal to the volume of cone X, which means either it is less than X or greater than X. Let's take it one by one. Case 1, if possible, let the volume of the segment of paraboloid be greater than X. Inscribe and circumscribe figures made up of cylinder or frusta of cylinders with equal height such that the circumscribed figure minus the inscribed figure is less than the segment of the paraboloid minus the cone X. That means the inscribed figure is greater than X. How? Because circumscribed figure will be greater than the segment of the paraboloid. Now, to maintain that equality, it means that the inscribed figure is also greater than X. Now, the greatest frusta forming the circumscribed figure has the base with the circular ellipse about BC and the axis OD. So, this is the circumscribed figure. The smallest frusta forming the circumscribed figure has the base with the circular ellipse about PP prime and axis is AL. So this is circumscribed frusta of cylinder. The greatest frusta forming the inscribed figure has the base with the circular ellipse about RR prime and axis is OD. So RR prime, OD is the axis. The smallest frusta forming the inscribed figure has the base with the circular ellipse about PP prime and the axis is LM. So this is the inscribed figure, smallest one. Now we are looking at the ratio of the first cylinder in EC, or rather I should say first frusta of the cylinder in EC, that is the bottommost, is to the first in the inscribed cylinder, that is the bottommost. They are proportional to the square on their radii. So that is BD square is to RO square. That would be in turn be proportional to AD is to AO. That is, the bases are proportional to their heights, and which in turn is equal to BD is to TO. So now we are looking at, when we say TO, we are talking of the cone. Remember this cone? The generator of that cone is AB. So here OT is the intersection of that generator with the line RR prime. Now that was the first cylinder, that is the bottommost cylinder. Now second from the bottom cylinder in EC is to second from the bottom inscribed cylinder is equal to HO is to SN. If we follow the same procedure for this, we end up with HO is to SN. And like this, we keep going through the various slices. So finally, we can say cylinder of frustum EC, the entire thing, is to the inscribed figure is equal to BD plus HO plus this plus this plus this plus this is to TO plus SN plus this plus this plus this. But BD is equal to HO. So all these are with respect to the cylinder EC. So the radii of the cylinder is equal throughout. And BD, TO, SN, they are in arithmetic progression, specifically diminishing arithmetic progression. This is from our proposition 1 in on conoids and spheroids. So which means from the lemma of proposition 1 that comes before proposition 1, we can say cylinder EC is greater than 2 times the inscribed figure, which means cone X is greater than 2 times the inscribed figure, because here cone X is equal to half the cylinder EC. So if cylinder EC is greater than 2 times the inscribed figure, it means cone X is greater than 2 times the inscribed figure. But we started off by saying that inscribed figure is greater than the cone X. So we have reached a contradiction. So that means an impossibility since inscribed figure is greater than X. So that was our first case. Now let's look at the second case. Only would the segment of paraboloid be less than X. Again, inscribed and circumscribed figures made up of cylinders or frusta of cylinders with equal height such that the circumscribed figure minus the inscribed figure is less than the cone X minus the segment of the paraboloid. So which means circumscribed figure is less than X. If we are saying that circumscribed figure minus inscribed figure is less than X minus segment of the paraboloid, and we know that the inscribed figure is less than the segment of the paraboloid, it means circumscribed figure will be less than X. Again, just like in case 1, we take it slice by slice. First, that is bottommost frusta in C is to first, that is the bottommost of the circumscribed figure is equal to BD square is to BD square, which is equal to BD is to BD. So here when we say frusta in C, we are talking of this entire cylinder, page CE. And circumscribed figure is the outer figure. Second from the bottom frusta in C is to second frusta in circumscribed figure is equal to HO square is to RO square, which is equal to the heights AD is to AO, which is equal to the HO is to TO is what? The radii of the frusta of the cone. And like this, we can keep going till all the slices are covered. So now cylinder C is to circumscribed figure is equal to BD based on this statements. BD plus HO plus, we keep adding up the radii, is to BD plus TO plus dot dot dot. Here BD, HO and dot 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 are the radii of the cylinder, and BD, TO and so on are the radii of the slices of the cone. Again, BD is equal to HO, all these will be equal, and BD, TO, SN dot 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 diminish in arithmetic progression. So which means this proportion we can write it as BD plus HO plus dot 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 is to BD plus TO plus dot 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 is less than 2 is to 1. Again, proposition 1, which means Since we have arrived at less than 2:1 ratio, that means x is less than the circumscribed figure. We started off by saying that circumscribed figure is less than x. So an impossibility, since the circumscribed figure is less than x. Now, since the segment of the paraboloid is neither greater than x nor less than x, it implies that it is equal to x. That means the segment of the paraboloid is equal to 1.5 times the cone ABC. So that was proposition number 21, 22 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.